Okay, hello everyone. Good night. All right. We will continue. Actually, today I just want to discuss for paper one SPM 2021. Okay. Because before this we never see the format, right? So what can I say? Okay, from the previous format. Okay, before the KSSM. The questions is quite challenging. Okay, it's quite challenging. Okay, it's not directly a direct questions. Means you have to know what concept is it used, then and how to apply it. Okay, they give you a situation, right? So it's not like very straightforward question. Okay, so it's quite different from the previous format, right? So we see for number one first. Okay, so this one is quite easy. Okay, so what is the quantity? Which quantity is a base quantity? So you already know that base quantity, right? For the base quantity means there is basic, means you cannot simplify anymore, right? Cannot simplify anymore. Example as mass, right? So example as mass. So mass must be in kg. And you remember the question about you need to calculate the impulsive force, right? Okay. So some of you, I think the teacher give you um the correction, right? It's actually 5 ms negative, and 5 ms. I think I am not mistaken. But some of you that you don't change the m to milli, so you take as a 5. So you got the wrong answer, right? So you know that is a time, right? So time it should be is seconds. So if there's m in front of it, it means it's a millisecond. It's not 5 seconds. Okay, I'm not sure whether you got the correction, mean the teacher tell you about the correction. But yes, there's the teacher already like paste it on the question paper, okay, on the plastic there, the outside one. So I think you must know. So 5 milliseconds. So you need to know what is it, what does the quantity there. If you say time and they give you the unit 5 ms, so you know the m is actually not meter, it's actually millisecond. Alright. If they say velocity, okay, f 5 ms negative 1. Yeah, that one is correct. That one, the m is actually meter per second. Okay, so you need to know the physical quantity, right? What is the unit for it? Okay, so for this one, the basic quantity that you already know is actually the currents, right? The mass, the time, the length, okay, and the light intensity, okay, and the number of mole, right? Yeah. So that's the example, okay, for the basic quantity. So if a power is actually a derived. So how do we know that it's a derived? Because we have a formula for power. P is equals to VI. Okay, this is for electricity. Or P is equals to work divided by time. So means you need to have a formula to find the answer. And even you know the power, even the unit for power is watt, right? But to derive it to watt, so V is actually what? V, the unit is voltage, right? And I is current A. So P is actually VA, right? Is the unit in power for electricity. Okay. But for the force, power is work divided by time. Okay, so work is Fs, right? So kg ms negative 2, then kg ms negative 1. So you can see there's more than one base quantity there. So let's see if I put it example, momentum, kg ms negative 1. So you see there is more than one base quantity here. Okay, they got three. Okay, so if base quantity is only got one unit, okay, one unit only, one quantity only. So for the energy, you know it's in joule, yes, but it's not actually joule, it's actually, it's just like the simply to simplify it, okay, it's joule, but actually it's derived. Okay, so let's say it's half mv square, the kinetic energy, right? So kg, mass is kg, v square is m square s negative 2. Okay, so this one, okay, and then of course you don't want to write this kind form of answer, right? It's too long. So we simplify it to joule. Okay, so that's why I said, okay, for the base quantity you must have only one unit. Okay, so now they have three units, kg, meter and second. Okay, then for current, okay, current ampere. There's no like formula, like to find what is the current. Okay, no. Okay, so it's actually the current is the base quantity. So you need to know to differentiate between the base and also the derived. Okay, for the base, okay, remember the seven things. I think for when you're form 4, we did this, I think during the PDPR, okay, the first chapter, you need to remember that one seven. So other than that seven things, seven quantity, yeah, seven quantity, all of that is a derived quantity. Okay, so just remember the seven, the length, the mass, the time, okay, and then the current, okay, and then the light intensity and also the number of mole, right? That one is for chemistry. Okay, another one, if I'm not mistaken, mass, length, time, um, temperature. Yeah, another one is temperature. So must be in Kelvin. All right. Okay. Then for number 2. Okay. Usually in the past year question, okay, not the KSM, the KBSM one, they don't give you a situation. They don't like give you this one, right? Okay, this is the situation. Then what is the concept? Okay. Usually they will ask you normally, what I mean that what does it mean by initial? Like very a simple thing. But this one, the question mostly got situation, and have to know what concept you have to use. Okay, so this one is it says the driver and the passenger of the car are advised to wear seat belts. So the seat belts prevent them from being thrown forward and hurting themselves. So the purpose of wearing seat belt is to reduce the negative effect of inertia, of course. What does it mean by inertia? Yeah, so that one you need to remember. The inertia is a tendency of an object to remain, okay, to its original, whether it's moving or is stationary, okay, unless there is a force exerted on it. Okay, the tendency for it to remain for its original position or original motion. They say if moving with the velocity, constant velocity, it will still move with the constant velocity. Okay, but if it's stationary, it will remain stationary. Okay, so for this one, right, we have a seatbelt. Okay, so when the car stop, what will happen to you? Okay, so what will happen to you? Of course, the bus will stop, but your body will still want to move forward. Okay, so the seat belt will, okay, push your body back. All right, so that is actually the inertia. Okay, for number 3. All right, so diagram 1A show Abu drops a box off a cliff at the height of 50 meter. Okay, so this is two situations. So if Abu does the same activity on the moon using the same box as shown in the diagram 1B, which quantity will increase? Okay, so we have to know what is the difference between the Earth surface and the moon surface. Okay, so the difference is actually the gravitational acceleration, right? So for the Earth, we already know 9.81 ms negative 2, but some of you still use 10. So remember, for those who use 10, I will not give you mark. Okay, I told you so many times you have to use 9.81. Okay, so now, all right, for the Earth is 9.81, but for the moon, okay, for the moon is actually 1/6, okay, from the Earth gravitational force. Mean you just time 1.6 times 9.8, or 1/6. Okay, 1/6 times 9.81. You got the gravitational acceleration for the moon. So mean the moon has less gravitational acceleration. So moon less gravitational acceleration. Okay. So the question asks, which quantity will increase? Okay. So The answer is said, the first answer is the time taken for the box to reach the surface. Yes, of course, because the acceleration is decreasing now, means the box will move slower, right? So the answer is A, right? The answer is A. All right, the weight, the weight is decreasing because W is equals to mg. Okay, so if on the earth you times what 9.81, right? Your mass times with 9.81. But in the moon, it's different. It's maybe like 1/6 times 9.81 times your mass. Okay, so it's decreasing. You want the one that increasing. Okay, so A increasing. But then the mass of the object, all right, the mass of the object is actually is same. Let's say if I go to Pluto, I go to Mercury, if I go to the moon, if I go to another planet, okay, my mass is the same. But the mass is not changing. The one that change is the weight because weight influenced by the gravity. So remember that, right? So the weight, the mass will be the same. The weight, of course, no, because different gravitational, and gravitational free strength also no, because I just told you it's 1/6 from the Earth, right? From the Earth gravitational acceleration, so it less. So the answer is A. Okay. All right. So number 4. Okay. This is the questions I think like almost same as the one that I asked you in paper 1. Okay. So I noticed that paper 1 most of you cannot get like 30 something. Okay. Even like 5M also I think got like 2 or 3 people. Okay. And I asked some of you, they said it's quite hard. Right? But for me, I try to give the easy one, but you say it's hard, but it's okay. Okay, we will discuss that one. All right. So Mei, right? Mei cycles from her house to school. On her way back from school, she stopped at the grocery store behind her house. Diagram 2 show a displacement time graph of her journey. All right, so remember, for this kind, there are two types of graph, right? We learn for physics. Okay, the first one is what? I think I already did this like 2 or 3 times already, but never mind, we do it again. Okay, so displacement against time, and this one is the velocity against time. Okay, so let's say the graph is like this, right? What can you get? What information that you can get from the graph from displacement against time? Okay, the gradient. Ah. So when you mention about the gradient in physics, you must know there must be a triangle. Even you answer in your paper 3, your Amali, I didn't see it yet. Okay. There should be, to find the gradient, you must draw a triangle. That's the basic thing. So of course, for this kind of graph also, you have to draw the triangle. But this one is just only small because you don't need to find the magnitude, right? But in the paper 3, I ask you to draw as big as you can. Okay. So let's say this is the, okay, the triangle. What can you say about the triangle? Triangle represent the gradient. Now the triangle is same size, right? All it is the same size. So means the gradient is same. So when the gradient is same, gradient is actually for the displacement against time, it represent velocity, right? So means the gradient is same, the velocity also same. Or we say the constant velocity or uniform velocity. So if we draw a graph, okay, if we draw a graph, velocity against time. So your graph, because it's the velocity is uniform, right? Because of the same gradient here, when you draw a triangle, they got the same size. So it should be like this. Okay? All right. Then I understand there's sometimes they didn't give you a straight one. Like me, I think my question is not a straight one. It's like curve, something like that, right? So it's a curve like this. So how do we know the gradient? Do we need to calculate it? No need. You just draw the triangle and you see the size of it. Right. So when I draw the triangle, the size of it becomes smaller. So mean when it becomes smaller, what happened here? The gradient is decreasing, right? Because the size of triangle is decreasing. So the gradient is decreasing. So the velocity also decrease. Yeah. So I mean decrease, it should be go downward like that. Okay. So that is the example lah. Okay. But let's say if like this, I give you another one like this, it curve like this. So if you draw the triangle, the size of the triangle is increasing. So means the gradient increasing. So velocity also increase. Then if you draw the graph, velocity will be up like that. Okay. Alright. So we go back. That is for displacement against time. Okay. So I already mentioned, okay, the gradient is represent the velocity. Please don't forget about that one. Okay. What is velocity against time? So for velocity against time, the two things that you can get, okay, from the velocity against time. First, the gradient is actually equals to acceleration, right? Okay, and the size, the area under the graph. Area under the graph is actually represent the displacement. Okay, so this is the area under the graph. Usually it's on triangle, it can be rectangle or trapezium or something. Okay, then you just find the area under the graph, you got the displacement. Okay, so this one is triangle, so half time base time height. Okay, but they say they give you in the form of the trapezium like this. Okay, so it's different thing. Okay, and you can count it, like you can divide it into three parts. Okay, so first one is the triangle, the rectangle, then back to the triangle. Okay, and also, or you can just directly use the trapezium formula. Okay, it's up to you which one you prefer. Okay, but then the way to find it, okay, okay, let's say if I have this one, okay, I already told you gradient is a triangle. So if I draw the triangle here, the triangle is same size, right? So when means the same size, the gradient is same, okay, same size, and the acceleration also same. So means uniform acceleration. So when you draw the graph for the acceleration against time, okay, so it should be like this. Okay, all right. But then they say it curve, right? Let's say it curve like this. Okay, so if they curve like this, it means the gradient is decreasing. So gradient decreasing means your acceleration is decreasing. Okay, if your graph, let's say this is a graph of v against t, okay, it's going the size of the triangle is become bigger, right? So means that gradient bigger, so the acceleration is increasing. Okay, so your graph will go up like that. All right. Okay, so at the end of the graph, you have to see, right? Sometimes they give you the like this, sometimes they give you but that one I need to remind you. This one. Okay. Sometimes they give you like this. Okay. Let's say lah, I just give a simple one. Okay, let's say this is 4, and then this is 2, this is 8, okay, and this is -2. Okay, example. Okay, and this one say 10. Okay. All right. So the question asks you, so this is graph velocity against time. The question asks you to find the displacement. You know, the displacement, if they ask you for the displacement, is different. If they ask you about the distance, it's different. Why? Because displacement, they got the direction, right? Means they have a negative, positive sign, okay, to show the object moving right, left, right. But let's say for the distance, they don't have any direction. They only have the magnitude. So we just ignore the negative signs, right? Okay, so I just give you this example. Let's say the first one, they ask you for displacement. Okay. All right. For the displacement, okay, you need to calculate all this, of course. So this one, let's say I give it like 9. Sorry. Okay. So this I use a trapezium, right? For this one, I use a trapezium. Okay. So A is half. Okay, and this one is 6 plus 9, right? Times by 4. Okay, the height, this is trapezium. So 2, 15, 30. Okay, right. So this is 30 meter. Okay, how about this one? Because it's a displacement, it's a vector, you need to include the negative. So for B, half times 1 because 9, 10 is only 1, okay, base, and the height is negative 2. So basically you will get negative 1, right? Okay, so then after that you add these two together. So 30 plus, okay, 30 plus negative 1, you will get 29 meter. That is the displacement. Okay. But let's say they ask you about the distance. Yeah. For the distance, you just ignore the negative. So if they ask you about distance, you don't put the negative here. Okay. The trapezium this don't have a problem because it's on positive side, right? So half times 1, okay, and then times 1 again. Just ignore the negative signs. No, sorry, 2, 1. Sorry. Okay. So we get 1. Okay. So now negative. So 130 plus 1, 31. See, there's a different answer. Okay. So you need to know what is actually the question 1. Displacement or distance. Okay. All right. So we go back to the questions. Okay. I hope you don't forget about this one. Okay. Now, right? It says which velocity time graph describe the movement of the Mei. Okay, sorry, I put it this one. Okay, so I divide it into, okay, O to P, P to Q, Q to R, and then R to S. Okay, that's the same as the graph, okay, given in the answer here. So from O to P, what you can see, I said what? Displacement against time. If you want to find the velocity, find the gradient. So draw the triangle here. So when you draw the triangle, the size is same. Means your gradient is same. And the gradient represent what? Gradient represent velocity. So means the velocity is same, constant. I don't say this is the answer. Okay, I didn't say this is the answer. Okay, I just said that this is the right graph. Okay. Okay, this one is correct. Okay, so far this one also correct. This one also correct. Okay, no problem. Okay, for this one, can you draw the triangle? No. How can we draw? You don't like this, huh? No. The gradient should be below part. Okay. The gradient, if you even like in paper 3, I saw some of you put the gradient like this, right? The gradient is below the graph. Don't put out from the graph. Okay, put it inside the graph, below the graph. Okay, so there's no way that you can draw the triangle like this. So means the gradient is 0 because you cannot draw a triangle. So the gradient 0, then what happens to the velocity? Velocity is 0. So PQ is at 0. So far all is 0. So you see, right? The question here before this, right? When I answered the past year question, right? They don't give you, like, and usually lah, for you can just know the answer. There must be like PQ suddenly, become downward. So we can, okay, this one wrong. So only left A and C like that. So far they keep, like still, yeah, still quite confusing, right? So this one, okay. So still all the answer is correct. Okay, now we go to Q and R. So we draw the triangle. Okay, I draw the triangle, right? And triangles is same, right? The gradient is same. But then, what is a different thing here? Okay, so for Q and R, okay, is a constant velocity, but in negative. Means negative mean opposite direction, right? In opposite direction. So when it's a negative, okay, because it's downward, right? Downward means even like if you if you learn maths, right? If the graph is downward like this, the gradient is negative. So means the velocity is negative. So at Q to R, the QR must be at the negative part. So now we can, we can put this one wrong, okay? Right, this one still right. Okay, at the below part. Okay, this one still right. Okay, this one still right. See? Then the last part, R and S. So R and S also have the same size. So the gradient is same. The gradient same means the velocity same. But then what is the difference here? The difference is the negative, means it still go down. Okay. All right. So it's still downward, still at the negative side. Okay. So it's still at the negative side. So this one is already wrong. This one still correct. This one, yeah, teacher, both of it, all right, is on the negative side, but they don't have same level, means the same magnitude, the same velocity. Okay, all right, that's a part of it. Let's say I saw you, I draw you a graph. Okay, okay, this is, they say this is the first one, and then the below part, the negative part, maybe is like this. So the gradient is increasing, right? Yeah, wait, the gradient is increasing. I draw this one. Yeah. Okay. So the gradient is decreasing. Okay, decreasing or increasing? Decreasing. Correct. Correct. Decreasing. So if it's like this, means the gradient is decreasing. Okay. So means the value of the velocity also will be decreased. But for this question, they only have a straight line. So means there is no change, right? Means there is no change. So you can just put B as the answer, not C. Because if C means at RS, there will be a different, the line will be different. It cannot be in the straight line. Maybe it will be, it's still straight line, but maybe it will curve like this or curve like this, all right? That one is depend. Okay, but for this one, it's a still straight line. So, but in the negative side, because the negative, because it's move in the negative direction, means whether it's a right or left, depend which one you interpret as a negative, as a left or right. Okay, so the answer is B, boy. Okay, the answer is B, boy. Okay, for today I will just only discuss, because I will not take like so long time, because I know it's already night, right? And yeah, I know, and this is Saturday, right? Saturday night fever. Okay. So I just go until maybe like 9:15, 9:20, like that, or 9:30. Okay. So let's say if you cannot follow, you just like, we are enough, we cannot do it anymore. Okay, just raise up your hand. See, this one is actually to help you. Okay. But then in class also, we will do the same thing. Okay. So diagram 3 shows the durian falls from a branch with a height of 5 meter. So what is the velocity of the durian just before it hits the ground? When it comes to the question like this, right, take out the info that given in the question. First, we know the height is 5 meter. So height is represented by what? Height is actually S. So your S is 5 meter. Okay? Your S is 5 meter. Sometimes when they say height, doesn't mean it's represent H. Okay, it can represent displacement also, because the unit is same, right? Meter. Okay, again, they can be represented by distance also, or length also. Okay, so you need to know for the question that asks you to find the velocity of the object, right? That one you need to use the formula. Remember, v square equals to u square plus 2as, right? S equals to half u plus v times t. AV is equals to u plus AT, right? That one, the three formula. Teacher need to remember? No need. The exam, I think that we give to you. Okay. All right. So after that, we use what are the information that we can know? So before the durian falls, what is the velocity of the durian? Is it the durian moving like that? No, right? Of course, you should be at the stationary before it falls. So you know, right? The u is 0. Okay. Then it falls under the gravitational acceleration. Okay, so what is your gravitational acceleration? 9.81. Okay, then the questions want what? It wants the velocity. Means it asks you to find the v. So you see here, you know three formula, right? V square v square equals to u square plus 2as, s is equals to half u plus v times t. Okay, and v is equals to u plus at, and sometimes there's another one s. I think that s equals to ut plus a plus half at square. Okay, if I'm not mistaken. Okay, you check back that one. Okay, so which one that you can use? Of course, we know we have v, we have u, we have a. You know, we want to find v. We have u, we have a, we have s, right? So we use this one. So you can refer to the formula in front, the page in front. Okay, then v you need to find. Okay, I just you can calculate this one on your own. Okay, and s is 5. Okay, then don't forget to square root 8. Okay, so you get the answer as 8. So I hope we maybe before like we discuss this one, we can, you know, like you can try to do it on your own. Or maybe you already buy the book, right? And maybe you already try. So this maybe can help you to explain why you got that answer. Okay, or maybe it help you to understand better. Okay, I hope lah. Okay, so diagram 4 show a rocket is taking off from the surface of the earth. Okay, what is the factor that influence the escape velocity of the rocket so that it can take off from the surface of the earth? Whenever they ask you what is the factor, you need to remember the formula. Okay, I know teacher, so many formula for chapter 3. Yes, I understand. Even like for me also, I have to refer sometimes, right, to the formula. But I think in the exam they will give you. Okay, so the escape velocity is what? V is equals to 2gm over r power, square or square root, right? Okay, so what is the constant value here? Your g is a constant value because it's 6.67 times 10 power negative 11. That one is a constant, right? And your m, okay, your m is actually your m is actually the mass of the earth, right? So mass of the earth also constant. Okay, it's always the same. Okay, it's always the same. Okay, so what is the one that can change? Of course, the r. So your r is actually from where? It's from, let's say this is the rocket, right? Let's see lah the example. Okay, so the radius is from this center to the rocket. This is the R. Okay, so it can be changed, right? It can be changed because our Earth is not in the circle. It's not totally a circle like that. It's a sphere, right? Means there's a change of the radius, right? So that one. So what is the factor? Of course, the distance of the object from the center to the Earth. The answer is C. Okay, for number 7, let's say you have a question. You can just like raise your hand or you can just open your mic to talk. It's okay. Alright. For number 7, it says which graph shows the correct relationship between the gravitational acceleration g to the distance r from the center of the earth. Okay. So from the center to the earth. So this, let's say I use this drawing. So from here, okay, from here goes to here, right? The gravity is increasing. Okay, but then when after it leave the earth, okay, the gravitational acceleration become decreasing. Okay, so that's why you got this kind of graph. Yeah, I erase first. Okay, so until r here means until r, okay, the gradient is increasing. Okay, so what is the value here? 9.81, right? Okay, but then when it move away from the earth, okay, let's say in the satellite, right? So it launched, okay, then it goes to the space, right? Then the gravity is decreasing like this. Okay, because when you know that the gravitational acceleration, okay, of course it will be less when you go, outside from the at the space there, okay, outer space, the gravitational is less of, that's why we are floating, right? Because that's why we are floating if we are on the outer space. So the answer is B. Number 7 is B. This one is actually also in the notes. Okay, for number 8, this one is the facts. Facts question. What does it mean by facts question? Is either you know or you don't know. Alright, means you need to remember. Okay, this is example, me you can just guess lah. But this one is a facts, mean you know, you don't know. Alright, so let's see. It says a geosatellite and also non-geo satellite. Alright, non-geostationary satellite. So what is the characteristic for non-geostationary satellite? Okay, so if you have the notes, I think of course you have the notes from Form 4, right? They give you already the difference of the characteristic of non-geo and also geostationary satellite. Okay, so the direction is same as the direction of the earth rotations. Okay, but for the non-geostationary is it must, the motion need not be the same as. Okay, so maybe it can, you don't, let's say the direction is not, cannot, it is cannot be same as the direction of motion of the earth, right? And the period for the geostationary is 24 hours, means 1 day. But for the non-geostationary, it can be shorter or longer. Mean the time is not same. It can be more or less. Okay, but geostationary above the same. Of course, when it's already mentioned about stationary, means it's not moving, right? So of course, you'll be at the same geographical location. Let's say we launch it in Malaysia, so it will be only at Malaysia. We will not move to another part. Okay. But for the non-geostationary, means it's moving above the different geographical location. Okay, maybe it goes to maybe another country, Singapore, Indonesia, right? Whatever is it. Okay, so that is a non-geostationary. So what is the function? Okay, for the geostationary, it's a communication satellite, right? It's like you're using your astro, right? So that one, a communication satellite. Okay. Of course, this one cannot be moved because when we need to communicate, right? Of course, there has to be a one that there has to be a stationary. If you move, then it's hard for us to communicate, right? To give the signal to the satellite, and it have to be reflected back to us, right? If we keep moving. So for the non-geostationary is Earth imaging. Okay, of course GPS, weather forecast, the one you use the Waze, the Google Maps, alright. Okay, and also weather, right? What will happen? You have to see the movement of the cloud, right? So that is a function of the non-geostationary. Okay, so example Mesat, and for Malaysia, this is Malaysia's one, lah. Tionsat, Razaksat, Pipit, and ISS. This one I think you already learned in Form 3. Okay. So, back to the question. What is the question asked? The question asked the characteristic of non-geostationary. So, we focus on this one. Sorry. Okay. So, non-geostationary satellite. It says the direction of the rotation is same as the direction of the Earth. Is it correct? No. Okay. It's not same as the direction of the rotation of the Earth. And the orbit period can be more or less. Yes, this one is correct. For the geostationary, it has to be same. It has to be 24 hours. But for the sorry, for the non-geostationary, okay, it can be more, can be less. It's used to communicate. No, okay, that one is geostationary. Like I told you, that the satellite have to be stationary, because if we want to send signal, then it keep moving. Then how we know, how we want to send the signal to the satellite if it keep moving? Then how it have to reflect it back to us, right? So that's why it's not using as a communication. It's used for the weather forecast. It's using for the maps, okay, Google Maps, all that lah. Okay, and for D, this one I said already, same geographical. Of course, that one should be geostationary. That's why stationary means not moving. So it should be, let's say They launch at Malaysia. So it will be at the Malaysia. Okay. So I think number 9, I think we will start until number 10. Okay, number 10. Then tomorrow no class. Okay, we continue on Monday, and Monday also I have class. Monday night, alright. I will do every night. If I can, alright. If I can, I try my best. Okay, I just hope that you can at least come. My class, or if you cannot come, you can just listen to the recording. We do it every day until your school open. Okay, my target is to finish the syllabus during the school holiday. Then when we open, right, we will do all the revisions. Okay, all the revisions. Okay, so for number 9, hmm, for number 9, so it says here a long jump athlete with a mass of 54 kg has reached a distance from a take-off point. What is the gravitational force between the athlete and the earth? So you want to find the gravitational between two objects. So you already know this is the formula. R square. Right. Yeah. Sometimes also forget. So M1 means maybe the athlete, M2 means maybe the earth. Okay, the mass. Alright. And then this one is okay. Alright. Sometimes okay, they give you in kg. So check the unit first. Check the unit first. Okay. Don't just simply just put in the formula, right? Check the unit. Okay, if mass all using kg, like the one you answer, they ask you for the elastic potential energy, right? Okay, you don't change it to meter, then you use the unit joule. It's wrong. Because if you want to use joule, you have to change it to meter first. I think I told you that one time. I said if you want to use the joule, okay. So actually whatever I said in the class is actually the one that always make mistake by the student. Okay. So you please take note. Okay, take note. Maybe you write something, or doing whatever. Try to remember. Don't make you know, you are in the correct way. Means you already know what the formula. But then when you substitute it, the wrong because of what? Because of the unit only. Then the answer is also of course wrong. Then you lost 2 marks there already, right? And your paper 1 is not that good. So the paper 2 that is actually that will help you a lot. Okay. And for those who answer for paper 2, right? Sorry lah cikgu membebel sikit kat sini. Remember the one that you need to choose the bed, right? So many of you choose wood. Okay, wood as the material for the bed, right? It's actually a carbon fiber. Carbon fiber is much stronger, okay, than the wood. Okay, so most of you, because of that, you choose L, but instead the answer is M. Another thing, the density. You said the density have to be high. Density is alright. So what is the helmet? Helmet is what? Helmet you use on your head, right? Did you want to put something heavy in your head? No. Right? It's a common sense. So you have to use the low density. So to have a light. That's the one also. That one is also you got wrong also. So I was like, oh my god, like this one you should not do. I mean, like, of course we don't put something heavy. They say, oh, why you have to put it heavy? I read the reason. The reason is to reduce the impulsive force. Okay, maybe I'm imaging the ball, hit the helmet, then what? The helmet. What is the function? You cannot move your head because you put something heavy in your head. What is the function of it? Okay, so sometimes physics is like quite a logic also. Okay, but it's okay. That's why it's called a trial examination. Okay, then let's try to do better lah. I mean that this is the last time you have an exam, right? After this, no. So let's try work it. I mean, like I will do the exam. I will do the exam once a while, okay, to make sure that to know that if it's an improvement of you. Okay, so F is G M1 M2 over R square. So this one, can you calculate on your own? Okay, all the already by given. I just give the answer here. So for number 9, the answer is C. Okay, this one you got actually 527.26, but we round off it to 2 decimal points, so 5.30. Okay, so you can calculate. I give you the formula. Okay, G already given. M1 is mass of the earth. And then the mass of the athlete is 54, also given. M2. And R is the radius, also being given in the question. So just substitute it, okay? Right, this is the last one. For number 5. Number 10, right? Diagram 5 shows a Y-shaped slingshot used by a student in an experiment to determine the value of V square of different masses of stone M. The relationship of the variable in this experiment is given by FD is equals to MV square. Alright. What is actually, okay? What is actually happened here? Okay. What happened to the, use what here? Use a rock, is it? Oh, stone. Okay. All right. Use a stone. Okay. And you see, they want you to find. You have to understand this one. Determine the value of v square of different mass. So two variables here: mass and also velocity. Which one is the manipulated? Manipulated is the mass. Okay. Because you want to know whether the mass influence the velocity, right? Okay, so what is the formula that use the mass and velocity? It's actually the kinetic energy. So I will show you how I actually derive FD is equals to mv squared. Okay, so it's actually like this. Let's say I put kinetic energy. I put it as F lah, right? I just put it as F because this one they use F, right? So F is half mv square. Okay. So I change it to here, it become 2F. Right? So it's actually D, the value is 2. If we just compare, right? We just compare. Okay, now we leave it with mv square. I want to find the relationship between m and v square. So 2F, okay? So 2F is actually this one divide, okay, m v square. Okay, so this one is actually a constant, right? Okay, of course you need to constant the force given by the uh when you try to pull it backward, right? The force must be constant. Okay, must use the same force. If not, all that become the variable is changing. There must be one constant variable. There is a force. Okay, you need to apply same force. So 2 is D, F is right? F is F, right? And the F is a force. And V square is actually what? It's a inversely proportional. Okay, so inversely proportional to the M. Okay, so let's see what's the question. What is the answer here? The gradient of the V square against 1 over M is equal to value of F. So we need to put Y is equals to MX plus C. Okay, so the C, there is no value of C here. Okay, so what is your X? Your X is the mass, right? Your X is the mass. Okay, and your M, they say it's M, but this one is a gradient, okay, not the mass. Okay, and your F is actually what? It's actually the 2F here, and you don't have C here. So the question said, the gradient the gradient of the graph is equals to 1 over m is equals to value of f. No, right? No, it's not equal. It's actually 2f, not f. Okay? And the velocity of the stone increase as the mass of the stone increase. No, because the graph is inversely proportional. Not, wait, this one I did, yeah. Is inversely proportional, right? When the mass is lower, the velocity become high. Okay. Then for C, all right, the product of F and D is always constant for different mass of stone. Yes. Because I told you just now, you have to apply the same force. Because of if not, all that will become a variable. All that changing, all the variable changing. Then you want to study what? All that changing, right? There must be one constant. Okay, two of course is constant lah. Right. So the answer is C. So you see, the question is quite hard now. I mean, like different. It's very different from the KSSM. Okay. And when F or is increased, D is increased. No. Okay. If you change, that one will become be divided by D, right? So your F increase, this one should be decrease. Okay. So the answer is C. Alright. So I will stop until now. We continue on Monday night at same time. Okay. So thank you for coming to my class tonight. So I see you on uh Monday on 10 a.m. Okay. Thank you everyone. Bye. Teacher, bye. Thank you.